Hello everyone, my name is Markus Tremmel, and today I want to present the results of a case study called COMTiles. This case study deals with the optimization of cloud-optimized tile archive formats for large or planet-scale tilesets and should significantly reduce the access charges and simplify the workflow for deploying large tilesets in the cloud, known from Slippy Map apps. For deploying large geospatial data in the cloud, different cloud-optimized formats have been invented in recent years. Also, for storing massive tilesets, different cloud-optimized formats have been created, like for example MBTiles, which is the most widely used and leading one in this field. In this case study, I tried to further improve these cloud-optimized container formats on the following topics shown on this slide by choosing a different file layout. The first requirement or goal is to support different tile coordinate reference systems. Then also the transferred amount of data and the number of requests should be minimized compared to other formats. Also, every tile in the archive should be requested with at most one additional request. As performance is crucial, fast decoding of the index should be achieved. To fulfill these requirements, a larger size of the total index has to be accepted, based on the assumption that cloud storage is in general cheap and additional storage costs are negligible. To fulfill the specified requirements, I have experimented with different file layouts and then ended up with the following file structure. First of all, there's a metadata section which is based on the OGC or on an OGC specification, which enables the usage of different tile coordinate systems. For specifying the offset and the size of specific tiles in the data section, an index is used. To minimize the number of transferred data and the number of requests, the index is basically divided into two parts. The first part is a compressed root pyramid, which contains an overview over the most frequent access tiles and in general is initially loaded. The second part is called index fragments and is used for lazy loading portions of the index. Fragments offer random access to portions of the index as they have equal size. To evaluate the efficiency of the layout, I compared COMTiles with MBTiles based on three different metrics, which significantly impacted the user experience and cloud access charges. For the transferred amounts of data from an object storage and the number of requests to a cloud object storage, two different realistic map interaction patterns have been selected. The first one is more zoom focused, while the second one is more focused on a panning-based navigation pattern. In both test cases, COMTiles outperform MBTiles by about factor 3 less downloaded amounts of data. In terms of the number of requests, both approaches showed no significant difference. Another evaluation was comparing the decoding performance of the index. In that case, COMTiles outperformed MBTiles by approximately 19 for country scale tileset and by approximately factor 63 for planet scale tileset. The performance advantages are basically based on the fact that COMTiles only uses a lightweight bitpacking encoding, while MBTiles is using an advanced heavy byte compression. This results in a by approximately factor of 10 smaller size of the total index of a MBTiles archive compared to COMTiles. But as said before, since cloud storage costs are cheap, we are assuming that additional about 800 MB are negligible. To further reduce the access charges, approach where individual tile requests are batched together were evaluated. This is possible since all tiles are ordered on a space filling curve. In the test, this could reduce the number of requests by approximately 77%. Future work may include further reduction of the index size while continuing to meet the specified requirements. One approach is to specify the presence of an empty fragment and encode this based on a bit vector encoding. This could reduce the total index size by about 50%. Thank you for your attention, and I wish you all a nice Phosphor G conference.